Hi, and welcome to this week's UMIP Community Review call. This week we're having our review call a little later than usual for pull request 558, which is to upgrade the DVM to 2.0. Chris, do you want to? I'll share my screen with the UMIP, and if you want to talk through it, that would be great.
Sure, I can do that. So yeah, a little bit of context before we get into the UMIP I can provide. Basically, we are going through a process of upgrading core components of the UMIP protocol. This UMIP involves upgrading how the voting system works at quite a fundamental layer, and we'll be changing like a lot of the tokenomics and how voter interactions work. And yeah, fundamentally, the primary changes see us introducing a staking system now in the new design. So UMA will now be staked within the DVM as opposed to being like a liquid token that's used against the DVM. And participation in votes now, instead of resulting in like rewards that you get paid per vote in the current system, you now earn a pro rata share of a fixed emission rate. So we've kind of changed the tokenomics in quite a radical way. The UMIP goes into quite a lot of detail around the specifications of why we made these changes and sort of the implications of them. And there's also quite a lot of documentation on the doc site that's currently in the works, as well as a bunch of articles. But yeah, fundamentally, it's around refreshing the tokenomics, hardening the shelling point mechanism, and overall improving how the UMA system works. One other detail that I probably should mention is this proposal introduces the concept of slashing, where basically if you vote incorrectly or against the shelling point on a price request, there's a penalty. And that penalty is reallocated to the people that vote correctly. So it kind of hardens the shelling point in the sense that you're rewarded even more than you were in the current system for voting correctly, and you're actually actively punished for voting against the shelling point. We can go into some specifications, but I thought that would be just a useful overview. The upgrade is quite involved in terms of the components of the UMA system that it replaces. And we can also discuss some details around that and what things actually need to happen in the upgrade process. But maybe we'll go through that a little bit later. Vari, how should we structure this? Should I dig maybe into some of the mechanism changes, or how would you like me to go about this?
If you would just talk through the UMIP, I can see there's a number of sections where you've got the reason, the rationale behind it, the specific changes that you're planning to make, and the security considerations.
Sure. Okay. So yeah, the motivation and rationale overlaps quite a lot with what I just spoke about now with the mechanism changes, but I can go over some more of the specifications, or some of the specifics rather. So basically, yeah, the current UMA system has some issues and some components of the mechanism that needs to be improved. And primarily, this can be broken into a few categories. So the first one that's listed here is around there's a perverse incentive in the current UMA system to create fake price requests to sort of DOS the system and earn rewards from this. You need to have a lot of UMA for this to be profitable, but it's kind of not a great incentive. And in the new design, we fixed this by sort of separating the rewards you earn from the number of requests there are. So there's no way to sort of bias the number of UMA that is emitted through these spurious requests. So that's what the first point talks about. The second one is, in the current system, it's actually difficult to know what the APY of the UMA system is. Like, there's no notion of like, you look at the emissions and you can work out the APY, because it's completely a function of the number of price requests. And the number of price requests are a function of like how often there are disputes. So it's not like deterministic necessarily. And this makes it difficult to sort of know sort of the return you're going to get from interacting with the system. which drives down engagement and just generally makes it more difficult to work out like what your return is going to be. With the staking system that I mentioned earlier, we now have a deterministic return. So if you stake UMA and you leave it locked for a certain period of time, you earn a certain reward. That's sort of guaranteed as a function of the emission rate and the amount of UMA that's supplied. Also, the current UMA system doesn't distinguish between governance actions and price requests. So what this means is in the current design, we actually punish you by not giving you rewards if you vote against the majority in a governance action, which is kind of weird because governance should be like democratic. It's not, there isn't necessarily a shelling point for governance, right? So if there's a price, right, or a data point or a question, there's a shelling answer that is like absolutely correct, but governance should be open to disagreement, and in fact, disagreement should be encouraged. And right now, we don't distinguish or delineate between these types of requests. So in the new system, you are not punished for voting against the majority with governance. You're only punished with governance if you don't vote. So non-participation is punished via the slashing behavior. Yeah, and then we spoke about dynamic enforcement of rewards. Yeah, we spoke about that a bunch. That's kind of related to the other points. The last point here is there's a locking system that we now have. So it's easy to enter the voting system in the new design, but a bit more difficult to exit. So you can deposit at any point in time, but to exit, you need to wait a unstaked cooldown of 7 days. This is obviously parameterizable by governance, but the core idea with this is there's a whole bunch of weird timing attacks that you can do with a staking and voting system. Like you could imagine unstaking right before a price request to avoid slashing, or doing other kind of weird things. Or let's say, for example, someone was able to actually take over the governance system and like extract value from UMA in some way. If you add a delay on the exit, it kind of fixes a lot of these incentive problems. So you now can't like unstake and then restake after a request to avoid slashing. And if someone was in the event to actually take over the protocol, you can't then like take over the protocol, steal money from the protocol, and dump the tokens. You like it basically enforces the concept of cost of corruption, right? Because you basically are like exposed to whatever the market forces will do after the action in the takeover. So this is kind of like a nebulous concept a little bit, but it takes some of the incentives that we had before and makes them like much more precise, right? In the sense that like the notion of cost of corruption is now like completely enforced, and it also makes it a bit more anti-fragile in the context of like the UMIP token price moving a lot, right? Because it makes it basically removes a lot of the supply from the liquid market, and if people want to sell UMA or buy UMA or whatever the case is, like the liquidity is locked in the protocol to remove. So it's kind of in some ways like a VE-nomics kind of mechanism, but like much more much less punitive and like kind of solving specific mechanism issues. Then the next section kind of delves into the incentives, which I mixed together here a little bit, but yeah, each of the points before are discussed as part of the new incentives. So I spoke about the staking at a constant emission rate. We spoke about slashing. This word slashing is a potentially difficult word because it has very negative connotations. I think when people think about slashing in this context, the right framing is to view it as like a reallocation between the wrong participants and the right participants. So if you continue to behave well in the system and vote correctly, this acts kind of like a bonus, right? And also to put some numbers to this, which we'll get to later in the UMIP, but the slashing is not designed to be like extremely punitive, right? It's not like you delete your money if you make one mistake, right? It's meant to like kind of represent the current system that we have. Then yeah, the third point here, this dynamic slashing library basically acts like a financial product library from previous UMA contracts. And this enables us to, via governance, adjust how slashing works. And slashing can be quadratic, effectively, as a function of other system parameters. In the beginning, it's a very simple, like fixed slashing amount, but in the future, we could design the slashing to be like a function of participation or whatever. You could imagine like the more contentious a vote is, the more we slash people who don't vote, for example, right? Because their votes are like kind of more important than, or any other like interesting model could be adopted. Yeah, the fourth point, governance votes are treated as a special case. We mentioned that just because governance should be a democratic process. I see there's some issues with the numbering here, which I can fix, but there's a spam deletion or spam protection mechanism that the DVM now has, which is quite a cool concept. So basically, in the previous DVM, if the DVM got DOSed, like if someone was to submit a lot of requests, we didn't really have like a graceful recovery path. But now we have a system where after a certain number of roles that a vote experiences, it's automatically dropped from the DVM. So you can roll a vote a number of times, and it basically gets dropped from the system, enabling you to like avoid the spam problem like almost completely. And the reason we need this from like a mechanism perspective is previously, if you spammed the system, as long as you earned more in rewards than you did from the gas you spent from voting, the system like will continue to operate as expected. But in the new system, because we've detached the concept of rewards from the number of votes you participate in, there's a point by which there's so many votes to vote on that you're going to spend more in gas than you earned in like the last month, let's say, right? And then it's the incentive compatible thing to do is to then not vote, right? Eventually, you could lose more in gas than you would be penalized from being slashed, right? It would be even worse. So this spam deletion kind of protects this, because if you were to DOS the system and like the shelling point is agreed to drop votes, then we can basically like purge votes from the system using this, which is quite interesting. The docs go into a bunch more details around this mechanism change and why this is necessary in the context of the staking system. But yeah, for now, it basically means we can accommodate someone DOSing the system, which is quite nice. There's a recovery mechanism where there's an emergency contract where users can be bonded, a very large bond, and this enables us to basically recover the DVM from basically any kind of failure mode that could occur. It kind of short circuits how the voting system works, and enables us, like in the event that, let's say, you could no longer commit or reveal in the DVM, right? How do we recover from this situation? And this emergency recovery system enables us to recover from that. It is designed in a way where if you were to do this maliciously, the voters will be able to block this action. And the only time where the system can work is when the DVM is broken. And the bond that we've set for this is extremely large. I think it's like 5 million UMA. We'll look later down in the specification section. So yeah, this is like a sort of an edge case to protect against, like, it's sort of future-proof any kind of breakage that the DVM could have, and kind of enables us to be very confident that even if the DVM system or even the staking system was to break, we can always have strong guarantees that we can recover the system in a decentralized way that doesn't put like a multi-sig behind it or anything like that. Then we also now have delegation within the protocol, which is really exciting. So you can delegate from your hot wallet to your cold wallet, let's say from your ledger to your phone, for example, or a wallet on your phone, and commit on the one and reveal on the other. And you don't need to use like a delegated voting or designated voting like we did previously. You can now do it as a first-class delegation within the protocol. And this is really useful for like individuals who want to vote and have like different security classes of wallets, but it can also enable like future protocols to be built on top of UMA, such as staking pools and other delegation systems can leverage the same technique. And there's quite interesting permissioning also around how the delegation works. So your delegates can claim and restake rewards on your behalf, but they can't ever access any of your like staked UMA or any of the rewards themselves. So that way, like if someone was to compromise your phone, let's say in the example I gave earlier, like the worst case scenario is that they could like vote badly, basically. And you could always revoke the delegation. Yeah, and we now have ancillary data included within governance proposals. This is just sort of a quality of life improvement to help with identifying governance actions more easily and better labeling them effectively within the system. And yeah, price requests also now have a unique identifier, like a number effectively that increments per request, which is seems like a small thing, but it actually helps quite a bit, because in the current system, it's kind of difficult to say like this is request 65, right? It's like it's always a function of identifier, timestamp, and ancillary data, but now we have an actual number with the request, so that increments over time. And yeah, lastly, was a bunch of gas optimizations that we added to the protocol, which were in some ways required to keep the gas costs the same with all this additional features, but primarily, yeah, it was kind of a refresh of the code because the DVM hasn't really been touched since early 2020. So it was kind of a refresh, restandardization, and an upgrade. Yeah, the next section goes over some of the implementation specifics of the contracts that are actually being changed within the DVM. So I'll quickly run through these, but basically the voting contract is replaced with the voting V2. Basically, all of these go from a V1 to a V2. So the same with the proposer and the governor. And then there's two new contracts at the bottom, which is the emergency proposer and this fixed slashing library, which accommodate the functionality I spoke about earlier with the emergency recovery system and the slashing library to calculate the reallocation of rewards between wrong and right voters. And as of earlier today, we've done the deployment. So these addresses listed here are the actual Etherscan links and the mainnet addresses for these payloads. And I would encourage people to verify the correctness of these and make sure everything looks good. And we also have some of the parameters that we're proposing to upgrade the system with. So this involves, yeah, quorum numbers. So this emergency quorum is the proposal size that I mentioned earlier. 5 million UMA needs to be bonded to submit an emergency proposal. This number we chose to be large enough that no single entity has this amount of UMA. And if there are large entities, they would probably need to coordinate to do this. The emergency executor is an interesting idea. So basically the way this works is if you create a proposal and it doesn't get deleted by the DVM, then, and it gets through a liveness period of 10 days, there is then a special account that only this account can actually execute the upgrade. Now, this account is the UMA Foundation Treasury wallet. And the idea is that the worst that account can do is choose to not execute the upgrade. But it's just an extra safety net in the event that something was to go wrong with this emergency system. There's like one account basically that can like pull the trigger and run the upgrade. It still requires a large quorum of UMA to submit, and it requires the DVM to not vote to delete this proposal. And it's kind of the final step in the process of like who can actually pull the trigger and execute the upgrade. Yeah, then this emergency minimum wait time is 10 days, like I just mentioned. The base slash amount is 0.1%. So basically what this means is for every vote that you either vote wrong or you don't participate in, and when I say vote, to be specific, I mean request. So you could have 2 price requests within one voting round. For each request that you get wrong, basically, you will lose 0.1% of your stake. And that is then reallocated pro rata with in and amongst the other voters. So this number, what we did is we tried to work out, based off the history of all previous votes within the DVM, what number do we need to set the slashing to such that the emissions, if you were to stake and not vote for an entire year, that your balance would remain flat, right? So the amount that you get slashed basically equates to how much you would have earned if we had the same number of votes that we've had since the launch of the DVM. So this is meant to be like extremely lenient, and the governance might decide to change this later, but basically it's set such that, yeah, what you earn is about the same as what you lose if the system continues to behave as it has in the past. Obviously, if there's more requests, then you'll lose more than you earn, but the inverse is also possibly true. And then, yeah, this governance slash amount, we spoke about this. This is the amount slashed for voting wrong on a governance request, and is 0 due to, yeah, a governance request being a democratic process, like I mentioned. Emission rate is set to 0 in the beginning. Now, the reason we've done this is that we don't want there to be a rush on people joining the system. So ideally, we need people to migrate and to stake, right? But we don't want there to be like a perverse incentive for people that can like stake very quickly to earn like drastically outsized APYs. But there will be a proposal probably 5 days to a week after the upgrade where we turn on the fee or turn on the APY, turn on the emissions, introduce this number to a non-zero value. So it's basically just meant to be fair in the sense that we normalize when we actually turn on the fees and sort of keep things as fair as possible. So that's why that's set to 0. This unstake cooldown, the idea of this is what I mentioned earlier around how there's a delay from when you submit a withdrawal request and when it can actually execute. That's set to 7 days. Phase length is the same as it is in the current system, where we have a commit of 1 day and a reveal of 1 day. And together this forms the phase length. The GAT is the governance activation threshold, which is effectively the same as what it is in the current DVM. We've kind of changed the quorum requirements slightly in this new upgrade. So in the current system, it's a function of the token supply, but now it's a fixed number. The reason we did this is the amount of UMA staked can vary potentially quite dramatically, whereas in the current system, like the amount of liquid UMA is going to be kind of a fixed size. So rather, we don't want there to be a situation like if you imagine it being a percentage of the staked amount, you could imagine as soon as there's like 500,000 UMA staked, a very small percentage of like the total UMA could then try and do some like adversarial thing and take over the system. So by having a fixed like numerical amount for the GAT, we bound the minimum amount of UMA that must be staked before governance can actually do something. Then the SPAT is a new concept that we've introduced. And basically this adds to how the quorum requirement works within the DVM. And the SPAT is basically a percentage of staked tokens. So it's this percentage of staked tokens that must participate and agree with an outcome in order for it to be considered valid. So for a vote to go through, we require both the SPAT and the GAT to be met. And there's a very specific reason that we've added this, and that is to create a shelling point around the notion of a vote deletion. So in order to delete a vote, we need to roll the request a number of times. And if we don't have the SPAT, if we just kept it the way we had previously with the GAT, then there isn't actually a way to achieve a shelling point on the do nothing action. So let's say you want to roll a vote, what you need to do is no one must participate and we mustn't hit the GAT. But if you have only like 5,000,001 tokens, then you can push through a vote that sort of validates it, prevents it from rolling, and you can block the deletion without actually having a majority. So the SPAT, what the SPAT does is sort of bounds the minimum participation within a vote and enables us to have a shelling point around vote deletion. So it creates an incentive compatible shelling point on literally doing nothing in a price request with the intention of rolling it. And yeah, so there's a more documentation around this on the UMA doc site that goes into why we need this from a mechanism perspective, but it's to create this incentive compatible shelling point on vote deletion, which otherwise is not possible without this introduction. Max rounds, or max rolls rather, is the maximum number of times that a vote can roll before it's deleted. So max rolls of 4 means that on the 4th roll, a vote is automatically dropped from the system and deleted. Max requests per round basically bounds the maximum number of price requests that the DVM can have in a round before they're automatically put in the subsequent round. This is also a new concept that we don't have in the current DVM. And the reason we need this is that this number needs to relate to the maximum slashing that a voter could receive in one round. So if you consider there being 1,000 price requests in a round, which is what the max requests per round is set to here, and the base slash amount is set to 1%. If you are staked and you are slashed 1,000 times linearly and independently at 0.1% per request, you will have a balance of 0 at the end of the round. If we had more than 1,000 requests in that round, then your balance would need to go negative, and that would break like logically how we can reallocate slashing given that we want rounds to be linearly independent. So this number needs to be related to the base slash amount and should effectively be 1 over the maximum base slash amount for a given round. Again, this is discussed more in the documentation, but yeah, that's basically the idea there, is to bound slashing going negative on a per voter basis. Proposer V2 default bond is the same as the Proposer V1 default bond, which is the amount of UMA you need to stake to submit a governance proposal. And then lastly, we have this voting upgrader address, which is a contract deployed to help with some of the migration processes. We're effectively swapping out the core voting logic as well as the governor, and there's a number of transactions that need to be submitted for this to happen. And this voting upgrader address is a sort of helper contract that we use in this process to do the upgrade in a permissionless way, right? Like the whole point of this upgrade is this is a proposal that we're putting forward that adds these new mechanism changes, and that we've spent a lot of time researching and thinking about and discussing with different people. And we need the upgrade process to be done in a permissionless way. So this voting upgrade address is a contract to enable this process to be done in a permissionless way, where we basically transfer some of the permissions of the DVM system to this contract, and then within the same transaction, we transfer those permissions to the new voting contract and the new governor. So yeah, it effectively enables us to do this in an atomic process. Yeah, so the section that follows basically discusses the upgrade process that we're planning on going through next week, and outlines the actual steps that need to happen. I'm not going to go through this like line by line because it's quite specific. But basically, I would suggest if people want to understand the exact details of this, there's a link to a README file in the protocol repo that has a very, very detailed discussion of the steps that need to be taken in the upgrade. And that will be part of the upgrade payload that we will vote on as part of next week's governance cycle. And yeah, that's basically what's listed here. There's 1 or 2 details that I should mention that aren't actually in the UMIP that Sean called attention to here. So one component that we've added here is that we've added a permissioned address that can actually execute the upgrade. So what this means is, similar to how the emergency proposal system is permissionless and who can submit it, we want to control who can actually pull the lever, right? Like when do we want to actually execute the transaction? The reason we want this is in the event that another price request is in queued, in between the time that we vote on the upgrade and when we execute the upgrade. If we execute the upgrade, that proposal will be lost from the DVM. And we don't want that to happen, right? We don't want a risk that we basically drop a price request. So the only reason we have this is that we can effectively delay until that price request has been resolved. And then we can pull the lever and execute the upgrade in such a way that there is no risk of losing any price requests. This account can't do, again, anything other than just delay. And that gives us a bit more confidence that sort of the intricacies of this upgrade will be done safely in a time where we're completely confident that everything will do what is expected. The last section in the UMIP is the security considerations. So this set of contracts was originally written in, I think, October last year, and has been audited 3 times now by OpenZeppelin. We have links to 2 of the 3 audit reports. They haven't published the 3rd one yet, but we will be linking to it soon. And OpenZeppelin has also audited the upgrade proposal and process that I briefly mentioned earlier, and that is linked to in the scripts up above. So that involves, the transferring of all the governance, ownership components, the voting system, and everything that we actually need to replace these contracts within the DVM and within the UMIP system. So that's basically the UMIP at a high level. We have, I think this is not the right venue to go like into too much detail on like a lot of the other mechanism stuff, which I think is really interesting. And there's a lot of like reasons why a lot of this stuff was done. But we have an internal learning session which we ran internally on this, and I think we'll have another public one at some point very soon to go over the reasons why this mechanism changes are required for sort of the future proofing of the UMIP protocol and sort of what it enables us to do from an incentive and a mechanism perspective going forward.
Thanks ever so much, Chris. That was really comprehensive and informative. I noticed there was a few things that were still outstanding, just kind of small issues. I just kind of wanted to invite people to ask any questions.
Yeah, I thought this was a really great walkthrough. I know that we've talked about this design and upgrade process a number of times, and it's been audited pretty thoroughly. So I think this is just a really good video to also share, because it's kind of a final walkthrough for the community to understand how the ins and outs of the voting process actually works, including all of these sort of like under the hood emergency type things, which are not likely to be activated, but important to consider.
Totally, yeah. I think we definitely should do another like internal learning session that's maybe like public facing around this. Ideally like very soon, just to like explain this in the context where we have a bunch of slides and other information and diagrams that I think would also be very useful to share with the community.
Yeah, that would be great. It would be good to do a session like that. And I think the community would appreciate it. This is going to be out with the usual commit reveal cycle. Can you talk a little bit about why that's been decided?
Yeah. So our goal is to submit the upgrade payload on Monday. And the commit day is on Tuesday next week, and therefore reveal Wednesday. The reason we wanted to do this is that if we did it otherwise, we would be needing to execute the upgrade potentially over the weekend. And there's a lot of moving parts in this process. There's a new voter DApp, which we've spent like 6 months building. And I think everyone will be like very happy to see it's really, really a really great DApp. It's got unbelievable decoding functionality and like request augmentation functionality, deep integration with Discord and a whole bunch of things. And there's a new website as well that'll be launching. Point being, there's a lot of moving parts, and we want to make sure that we don't like need to do that on a Sunday evening kind of thing. And if we can do this earlier on in the week and have the entire week to like be very confident in the correctness of things, it just will make the cadence a little bit better. So that's the primary reason. And also like gives the community some time to sort of look into the new DApp and play around with it and all of that before we have the next vote. So that's the main reason. It's just this is an atypical proposal in the sense that it's upgrading the protocol pretty fundamentally, and we want to have enough time to do everything as thoroughly and as carefully as possible.
Super, thanks, Chris. Any further questions? As far as I can see it from as you were going through, it looks like a goal with 4 conditions. So there was the issue of the numbering. There was adding the discourse link. There was
I've added that already.
Oh, okay, sorry. There was permissioned execution contract.
Mm-hmm.
Is that right?
Yep.
And The other one that I wasn't very sure about was the link to the OpenSeclin audit. Does that need to go in before we vote on the UMIP? Or
So we've added the first and second audit. It's just the third one that we don't have at this point.
okay, cool. So it's a go with 2 conditions. Number and permissioned execution contract.
That sounds good. Yeah, awesome.
Everyone in agreement on that?
Yep, sounds good.
Super. Thanks to everyone for turning up, and especially thank you to Chris for talking us through quite a complex upgrade. Is there anything else people want to raise? Well, thank you again.
Thank you.
Thanks, Chris. Thanks, Rory.